Today, we're diving into an industrial powerhouse, the Rotary Cone Vacuum Dryer, or RCVD. If you're in the food, pharmaceutical, chemical, or mineral industries, this technology might just be the drying solution you've been searching for. Let's break it down. What is RCVD? The Rotary Cone Vacuum Dryer is a specialized drying machine used to remove moisture, solvents, or residual solvents, LOD, from powders, granules, or slurry materials. It works by rotating a cone-shaped drum filled with material, where hot utility circulates through the jacket surrounding the drum. This heating mechanism causes moisture to evaporate at lower temperatures, making it ideal for heat-sensitive materials. Think of it as a giant tumble dryer, but specifically designed for industrial applications. Uses and applications. RCVDs are used in a variety of industries to handle different types of materials. Solvent media powders. These can be dried effectively by removing moisture or solvents. Heat-sensitive materials. RCVDs allow for drying at lower temperatures, which is perfect for sensitive materials that cannot withstand high heat. Materials that require fast drying. For certain materials, the RCVD can provide quick drying times due to its efficient vacuum system. Granules, powders, and slurries. The dryer is ideal for processing grains, small pellets, medium-sized powders, and even liquid mixtures, which are common in chemical and mineral industries. Key parts of an RCVD rotary cone. This is the heart of the machine, where the material is placed. The cone-shaped drum rotates 360 degrees, tumbling the material for even drying. Baffle. Inside the drum, baffles or blades agitate the material, ensuring that it is evenly mixed and exposed to the heat, which helps promote uniform drying. Heating system. Hot water or thermic oil circulates in the jacket surrounding the cone, providing the heat required to evaporate moisture from the material. Vacuum system. The vacuum system creates a low-pressure environment inside the dryer, lowering the boiling point of solvents and moisture. This allows drying to take place at lower temperatures, which is especially useful for heat-sensitive materials. Inlet and outlet ports. These ports allow the material to enter and exit the dryer. For air-sensitive or toxic materials, a glove box can be used to ensure safe handling of the material during the drying process. Working principle of RCVD. Wet material is loaded into the rotating drum through the inlet. As the drum rotates, the material is tumbled, ensuring it gets evenly exposed to the heated surfaces. The heat from the jacket and the vacuum system causes the solvent or moisture in the material to evaporate. The evaporated moisture is then removed via the exhaust system, leaving behind the dried material. Limitations of RCVD. Despite its versatility, the RCVD has some limitations. Hygroscopic materials. Materials that absorb moisture from the air cannot be processed in the RCVD. Sticky materials. Materials that tend to stick to the surface of the drum should be avoided, as they can interfere with the drying process and lead to inefficient operation. Selection of dryers. When selecting a dryer for your specific application, consider the following. Occupancy. Ensure that the RCVD is filled up to 50% of its capacity for optimal performance. Avoid loading the dryer with less than 20% or more than 80% capacity. Material compatibility. If you are processing acidic materials, a dryer made from glass is ideal. For neutral or basic materials, stainless steel is commonly used. However, always perform a coupon study before finalizing your choice to ensure compatibility. Lab studies. Prior to full-scale operation, perform lab studies to determine key operating parameters such as drying time, inlet temperature, pressure, vacuum level, and the nature of the material. This helps to ensure that the dryer will operate efficiently and safely in your specific conditions. Summary and key takeaways. The Rotary Cone Vacuum Dryer is an efficient and versatile drying solution for heat-sensitive materials, solvent media powders, and slurries. It provides the ability to dry materials at low temperatures thanks to its vacuum system, which lowers the boiling point of solvents. Understanding its key components, working principle, and limitations is essential for making the most of this technology in your production process.